Okay, so these video notes are over introducing logarithmic functions. So we're just really going to be going from logarithmic form to exponential form and exponential form to logarithmic form. So here, you can write an exponential equation as a logarithmic equation and vice versa. If you have an equation b to the x power equals a, that's the same thing as log base b of a equals x. So your base of your exponential function is still the base of your logarithm. Your answer to your exponential function is what you're going to be taking the logarithm of, and then your exponent of the exponential function is your answer to your logarithm. So going from logarithmic form to exponential form, if I have log base 8 of x equals -2, my base is 8. My base is 8. I'm raising it to the -2nd power, and that equals x. And I'm not going to worry about solving right now. I'm just going from one form to the other. I have log base 3 of x equals 4. So my base is 3. I'm raising it to the 4th power, and that equals x. This one's a little different. I've got log of 100 equals x. So what's missing here is the base. When there is no base written, it is an implied base 10. So you can write it if you would like. So my base is 10. So 10 to the x power equals 100. My next one, log base x of 16 equals 2. So my base is x. I'm raising it to the 2nd power, and that equals 16. I've got log base 12 of 12 equals x, so my base is 12. I'm raising it to the x power, and that equals 12. And last example on this page, I've got log of x equals 10. So the base isn't written, so it's an implied base 10 to the 3rd power, and that equals x. Okay, now I'm going from exponential form to logarithmic form. So I have 3 to the x power equals 16. So I always start off with writing the word log. My base is 3. Log base 3 of my answer is 16, and that equals my exponent, which is x. And this is read log base 3 of 16 equals x. Next up, I've got x to the -2nd equals 25. So I've got log base x of 25 equals -2. And this just takes practice, getting used to going from one form to the other. I've got 10 to the x power equals 987. This one can be written two different ways. So first off, I've got log. My base is 10 of 987, and that equals x. And the way that it's going to be written most commonly, because our base is 10, that's a common logarithm, so we don't have to write the base. So we can write it as log of 987 equals x. I've got 5 cubed equals x. So it's log base 5 of x equals 3. Okay, so this is just more practice on going from one form to the other. So log base 3 of x equals 8 can be rewritten as 3 to the 8th power equals x. Log base x of 2 equals 7 can be rewritten as x to the 7th equals 2. Log base 4 of x equals 12. That can be written as 4 to the 12th equals x. Log of 4, it's not set equal to anything, so you can say it's set equal to x. So that's 10 to the x power equals 4. Going from one form to the other, exponential to logarithmic, 10 to the x equals 7. So that's log base 10 of 7 equals x, which is just log of 7. Oh, it's not writing. Log of 7 equals x. X to the fourth power equals 8, so that can be log base x of 8 equals 4. 3 to the second power equals x, that can be written as log base 3 of x equals 2. And 5 to the x power equals 39 can be written as log base 5 of 39 equals x. That's a 5, by the way. My pen's not writing very well. And now we're actually going to go into solving, and solving is pretty simple when you go from logarithmic to exponential. So I have log base 5 of 25. It's not set equal to anything, so you can say it's set equal to x. So putting this in exponential form, we can say it's 5 to the x power equals 25. And common knowledge tells us that x equals 2. Next up, I've got log base 2 of 1/4, and then we set it equal to x. So putting it in exponential form, I have 2 to the x power equals 1/4. And going from a whole number to a fraction, we know it's going to be a negative. So x equals a negative 2. Log base 4 of negative 4, set equal to x. So 4 to the x power equals negative 4. And this is a trick question. There is actually no solution here. There is nothing we can raise positive 4 to make it turn it into negative 4. I've got log base 12 of 1, set it equal to x. So putting in exponential form, 12 to the x power equals 1. And anything to the 0 power equals 1, so x equals 0. And then log base 1/2 of 1/2 equals x. So 1/2 to the x power equals 1/2, which means that x has to equal 1. And that is it for our introduction into logarithms.